in this video we're going to talk about function rules, tables, and graphs. So first of all, you need to know what a function table is. A function table organizes the input rule and the output rule of a function. The independent variable is the input value, or the x value. The dependent variable is the output value, or the y value. Remember that this independent variable is going to go on your x-axis. It's also known as the x value. So it's going to go down here. And your dependent variable is going to go on your y-axis. That's why it's your y value. Okay, very important concept number one. There's three views of a function, three ways we can look at it. We can look at it as just the rule, such as y equals 1/2 x plus 3. We can see it in a table where we've got our input values over here and our output values over here, and in the middle of the table is where we're actually applying it to the rule. Or we can see it as a graph. And from the graph, we can find our rule. Okay, so very important thing to remember is the three ways we see a function. Okay. We've got to be able to complete a function table. So if you're given a function such as negative 3x, you need to be able to put it in a table where your x goes on one side, or your input, your output goes on the other. Then in the middle, you have that function rule, and you do the input and output. It's like a little machine where you input one thing, you do some stuff to it, and you get out something else. So here, I use the input values of -2, -1, 0, 1, and 2. My function was negative 3x. So each time I'm going to apply my -3 to that input value to get out my output value, or my y. So -3 times -2 gave me 6. -3 times -1 gave me 3. -3 times 0 gave me 0. -3 times 1 gave me -3. -3 times 2 gave me -6. So for every input, I have an output. Okay, so I've repeated this 3 times for each table. You should always be able to create a function table because that's one of the 3 views of a function. Here it was 1/4. We can do functions with fractions, we can do functions with decimals, anything. You've got to be able to work with every operation. So using my same input values, I used the function 1/4 x. 1/4 times -2 gave me -1/2. 1/4 times -1 gave me -1/4. 1/4 times 0 gave me 0. 4 times 1 gave me a 4th. 4 times 2 gave me a 1/2. Same input values, different output values because I changed my function rule. Here again, same input values, but a completely different set of output values because changed my function rule. Here they're going down by a step each time. Notice on this one I had to apply my same switch change rule. Even here in the land of functions, same switch change still applies. So again, input of -2, output of 10, input of -1, output of 9, input of 0, my output stayed 8, input of 1, output of 7, input of 2, output of 6. Input and output, that's what functions are all about. You put it in, you do something to it, you get a different output. Whoa. Okay, so what happens when we have a function, we use our table, then we've got to be able to graph it. So here, my function was the absolute value of x plus 1. So I'm going to start by using my table, using my same input values, -2, -1, 0, 1, and 2. I'm going to do all that. I come out with this output, -3, 2, 1, 2, 3. Now, this is still a function. None of my x values repeat. That's the definition of a function. My y's certainly repeat, but that's okay. So here's my set of coordinates that I'm working with. -2, 3, -1, 2, 0, 1, 1, 2, and 2, 3. So I'm going to plot them and I get this v. When you plot any absolute value, you're always going to get a v. This +1 causes it to move up by 1. So here's my function. I can do my vertical line test anywhere on this function and it's going to pass. So I know it is a function. That is what it looks like. So again, I took my rule, I put it into a table with input and output, and I was able to graph it. Okay, let's look at another function and graph it. Okay, this time instead of an absolute value function, it's an x squared function. So I said f of x equals x squared plus 1. So again, I used the same input values, I plugged them in, got my output. Once again, I do have some repeating y values. But it's okay, because by definition of a function, y values can repeat, x values cannot. None of my x values do, so it's fine. I've listed my coordinates down here, and now I'm going to plot them. Unlike the last graph, this is a u, or a parabola. So it's a different type of function, but once again, if I did my vertical line test, it would pass. So this is indeed a function. So I started with the rule, went to a table, ended with a graph. All three views of a function. So where can we apply functions in the real world? Let's look at a problem. Juan charges $3.50 per hour for babysitting. I want you to write a rule to describe the amount of money, represented with an M, earned as a function of hours. H, spent babysitting. So when we say M is a function of H, that means that M is going where your Y is, and H is going to go over there, where X would be. So our function rule would be M equals 3.50 H, or $3.50 times H, times the number of hours spent babysitting. So here is our table. I just chose a certain number of hours. He can go from 0 to 4. So here's my hours, here's my input, because my H is where my X is, then I plug it into the rule. 350 times 0, 350 times 1, 350 times 2, times 3, times 4. So what do we get out? Well, if he doesn't babysit any hours, he obviously makes no money. If he only babysits 1 hour, he gets $3.50. 2 hours, he gets $7. 3 hours, $10.50. 4 hours, $14, and so forth. Okay, we can still take all of this and plot it on a graph. Time, as I talked about before, is typically going to be your X value. It's going to be your independent variable, because time controls how everything else is going to go. Money is dependent upon the time. How much money you make is dependent on how much time you spend babysitting. So notice that as our time increases, our money increases at a steady rate. So we do have a straight line. Does it pass our vertical line test? Absolutely. So money, or time, is now a function. Money is a function of time. And this is how we can apply functions in the real world.